use Excel. Like when I work out problems by hand, sometimes I do the calculations in Excel, but then show them again by hand. So yeah, you can do it that way. Let's just do another really quick example here. Would everyone send me a piece of information? I'd like each of you in this class to send me this piece of information. Let's see. Oh, I know what we'll do. Rate your comfort level on a scale of 1 to 10 with how comfortable you are right now with the idea of standard deviation. I'll write the question down, and then I'd like each of you to send me a number from 1 to 10, and I'm going to put it into the spreadsheet. Rate your comfort level on a scale, comfort level with the concept of standard deviation, not the calculations yet. On a scale from 1 to 10, with 1 is very uncomfortable and 10 is very comfortable. So send me some numbers. I see 6, 7. I'm going to set up the data and then go back and get your stuff here. So person 1, person 2. I think we only have about 10 in here right now, something like that. So I'm going to just put the scores here, and we're going to do this kind of a little bit fast, okay? Okay, good, good, good. So I've got these numbers that I'm looking on my screen. I see 6, 7, 6, 7, 5, 5, 6, 7, 5, 5, 4. I'm going to put yours at 7.5, Shannon. Take the average of those two. So 4, 7.5, and 6. 4, 7.5, 6. And let's see if we can get just anyone else here. Maybe that's all we have. Yeah, I think I got everybody. 6, 7, 5, 5, 4, 7.5, 6, and 9. I love it. Great. All right. So now we could do this pretty easily by hand, but let's use Excel. And I'm going to write these steps out a little bit more neatly for you. So the first thing we're going to do is calculate the mean. Mean equals the sum of all the scores divided by n. Secondly, I'll do these one step at a time. So let's get our mean. I think I'll put it right here. And let's do it manually. Equals the sum of all the scores. Here I can just select them. I'll put a closing parenthesis and divide by n, which is 10, because I can see I have 10 people. So our mean is 6.25. The next step is to calculate deviations. Deviations equals x minus m. Deviation, and I'll write x minus m. And so let's take each score. So equals, and I'll click in the first score. I'll put my minus sign and I'll click on the mean, but I have to be careful and tell it, for all the rest of these, just stay in row 5. So I'm going to put that $sign before the 5. That makes sense. 6 minus 6.25 should be minus 0.25. So let's go ahead and calculate everyone's deviation. Okay, looks like good deviations. Our next step. Oops, get my draw menu. Three, we're going to square the deviations. In other words, x minus m squared. And so let's go ahead and get the squared deviations. I'm just going to put the square symbol up here so that we know what we're doing. And so we'll just take equals and we'll click in the deviation and we'll hit the up caret and the 2 to indicate squaring in Excel's language. So now we've squared it. And here we can just copy all the way down. Control C, Control V. Those are the squared deviations. Now we need to get the sum of squares. Sum of squares. And the sum of squares is or SS equals sum of squares equals the sum of all of those squared deviations. So let's type equals sum. And let's select all these squared deviations and hit enter. Next, we calculate our variance. And the variance is just sum of squares divided by n. And this formula for variance, we're going to be using it for the rest of our course. So the sooner you memorize it, the better. And so the variance equals sum of squares divided by, and I know that n equals 10. Enter. Finally, standard deviation. So standard deviation equals SD equals the square root of the variance. By the way, if you try to type in a formula for this, there are different formulas for standard deviation depending on the situation. And we'll learn about another one later, but you can't just type it in here because you don't know what formula it's using, so we calculate manually. So we'll type our equals sign, and I'll just write SQRT. See how it helpfully pops that up for me in case I'd forgotten? It tells me what it's doing. And opening parenthesis, the square root of the variance. There's the variance. Now our work is done as far as that goes, but let's go ahead and find the median and the mode through our manual practices. We could use the formula, but let's see if we can do that sort, and then we'll do the formula and see if it's the same. So I'm just going to sort these data. This button that says my data has headers is clicked. So that means it's looked above and it saw that I labeled that column X. So I'm going to sort by column X. So now we know that we have 10 scores. So we know the 5th and 6th should be in the middle. We could just count in this nice small data set. 1, 2, 3, 4. 1, 2, 3, 4. This should be our median. Is 6. And if we were to look at mode, it looks like our mode is also 6. And so what can we say about the comfort level of students in this class? I would say, I might be able to say on average, I would say maybe students typically reported a comfort level slightly above mid-level. Students, let me type, it'll be a little bit neater for you to read. Students reported a comfort level with standard deviation that was slightly. Now I'm going to take this and put it into a text box so that my work is a little bit neater and finish my statement. And I'm just going to tell it I want it to be that big. Okay. Students reported a comfort level with standard deviation that was slightly above the mid-range of the scale. I'm not sure if this is perfect, of the 10-point scale. Maybe I'll talk about the range here. The scores ranged from 4 to 9. And the typical distance of any score from the mean was approximately there's a typo there, I recognize. 1 point, well, let's say it was approximately 1.36 points. That might be a good way to state it. I think in here, I'll add a little more clarity and I'll type in parentheses, mean equals 6.25. And I think I can say one more thing. I can say the distribution was not skewed as indicated by the close proximity of mean, median, and mode. So they're all pretty close, right? We had mean, median, mode pretty close. So I think we could say that. So that's how